The mission of ISM is to build an ecosystem in India where chips, etc., semiconductors are manufactured in India.
How big is the semiconductor industry?
It's like asking how big is the market for iron, right? It is not just the iron ore industry or the steel making industry. It also goes into automobiles, it goes into pretty much everything, right? So, similarly here, the market is as big, electronics, digital, everything, right? But if you were to just tightly define it, it's probably $50 billion right now in India. India has today about 15% of the global integrated circuit design workforce. So there is technology talent in India. The government wants to reduce that pain of capex, and they have allotted about 76,000 crores, including up to 50% support in some cases of setting up those plants and all that initially.
Hi Ram. So, lot of discussion these days happening about semiconductors, and while it looks all fancy and geeky, not many people seem to understand it. So I thought, why not have a discussion today on semiconductors, what they are, what it means, what is India doing, and what are the implications for the market, etc. So let me begin by asking you, what exactly are semiconductors in as simple a language as possible?
Okay, let's come to the basics here. The very word semiconductor means it conducts something, and it semi means it is sometimes on, sometimes off. Semi-final, not there in the final, but close enough to the final. In cricket, IPL, we say, right? So, what does it conduct? It conducts electricity, basically. So, semiconductor is something, a material that can control the flow of electricity. So, if electricity is going through, it is a 1. If it is not going through, it is a 0. And as most people know, most of today's computer science software essentially boils down to those bits and bytes, which are nothing but ones and zeros. And those ones and zeros in sequence can determine numbers. And I'm getting into software now, but software essentially is again driven by ones and zeros. And so the more you have something called gates which control. When we started learning programming, more than 30 years ago, assembly programming was very important. And in that, actually, nowadays nobody does assembly level programming, but in those days, assembly level programming was taking you more close to the metal, where you actually control the ones and zeros at a program level. Okay. Now this is software, but semiconductors are basically hardware, where the electricity controlling is happening at a metal level, and the most common material used is silicon, right? So silicon is 99.9999% purified and used for this. Now you may ask me, why only silicon, why not iron, why not copper, etc. And the answer to that is, it's not only silicon. There are other materials like germanium, etc. But silicon is very crucial. Because it's got basically 4 electrons. It's called valence electrons in your physics chemistry if you go back to class 9, 10. And so they are very stable. And so they are able to conduct very well. Second is that silicon is the most, after oxygen in this earth, the most abundant element is silicon. All your beach, there's so much silicon everywhere, all over the beaches. So it's basically sand. Silicon is nothing but sand. And we all say, okay, Silicon Valley in California or India's Silicon Valley. That word silicon essentially is all coming from sand. It's it's all your beach bums or beach buddies who are all over the place. So it's abundant. It's got a stable structure, and most importantly, at high temperatures, it conducts well. So there are other materials like germanium, which were used in the earlier computers, but now they're limited to only those cases where you need extremely high speed conduction. But for general conduction in stuff like computers and laptops, etc., जो रोजमर्रा की चीजें हैं उसमें silicon is more than enough to do the needful. There's another material called gallium arsenide, which is also pretty good, but again that is used in cases like satellites and radio frequency, where the requirements are somewhat different. So that explains why silicon has such a key role in our day-to-day life.
That's a beautiful explanation of what exactly is silicon and how it is related to semiconductors. So what I understood is that these semiconductors are essentially uh, metals or things like metals, elements which help in the flow of electricity. They control the flow of electricity. Sometimes it is on, sometimes it is off. But why is it so important? I understand that these are all, all our gadgets, etc., work on these semiconductors. But why has it become so important that everybody is talking? Why is it so critical that the government is spending huge amount of money on this?
Yeah. See, basically, today, electronics is everywhere. It's part of our life. We are all living digital lives. And silicon is basically enabling that. So you have these wafers which are packed with trillions of uh, uh, semiconductors or transistors, and they are helping you have more and more sophisticated applications. So India today, a lot of these unfortunately are imported from outside. So in a situation where, let's say, there is war and your enemy countries refuse to give you access to electronics and technology, or let's say some powerful country wants to sanction you, and without naming those countries. So you got to have control of your own future. So that is the reason why the government is also woken up and said, look, we have to build our own infrastructure in this place. So it now means that we have to build our own silicon wafer manufacturing plants. We have to build the whole design ecosystem and all of that.
Okay, so I understood that it begins from the beaches and probably ends up with smartphones. So what is the entire value chain from beaches to smartphones? What are the various stages?
So, like in any industry, there is an R&D process. You design what you want in your chips, right? And then you build it to scale. Now, here the two things that is very important to understand is what are called wafers and chips. Now, obviously, I'm not talking about those chocolate wafers and potato chips, right? So, the first process, the manufacturing starts with the wafering, which basically means that you take silicon that's available after it's purified, and it's heated up to 1400 1500 degrees centigrade, and then they form those extremely thin ingots with it.
That is why they are called wafers.
That is why they're called wafers, and these wafers are by using diamond to cut it. Diamond wires are used to cut them into extremely thin layers.
That explains wafer thin.
Wafer thin, exactly. So that's why it's called wafers. So coming to the wafers, there are three levels of thickness of the wafers. The size of the wafer: 8-inch, 12-inch, and 18-inch. So 8-inch is the older technology, 12-inch is what is going on now, and 18-inch will be the future technology. So which means you can pack more. I mean, these are like extremely densely packed. Much more than what, let's say, New York City looks from space. So once the wafering is done, the next step is what's called the doping process. Just like gold can be used only after adding some impurity to it, right? You add some other material, copper or something, so that you can make jewelry and start wearing it. You just can't use pure gold. Similarly, in pure silicon also, they add certain, another element like a phosphorus, etc. So that this 4-electron thing becomes 5 electrons, which can be used then for actual switching. The semiconductoring work happens in that. So once the wafer is in place, then there is an advanced manufacturing process which got like multiple steps. I also don't understand those steps in detail, but sufficient for us to know that one is the substrate preparation phase, and then the photolithography, which is basically, it's like photography, but you're using it to actually print those circuits into place. Imagine it's like 3D printing, but happening at a much more miniature scale, right? And then you interconnect them and then superimpose a certain metal so that it becomes stable once So obviously in all of this, there's a lot of design that goes in, and the transistors are overlaid, and that's the whole process. In a nutshell. So now, but Moore's law, we've heard of Moore's law, right? Basically, more and more transistors are getting packed, so that is also at play here. And scaling it up is the other big game.
Okay, when it comes to semiconductors, we often talk in terms of nanometers. So, what is the significance of nanometers in this?
So think of nanometers as spacing between those transistors which are getting printed. I mean, in a layman term, I would say that is what it is. So the lesser the spacing, the more stuff you can pack into your chips, right? So today 5 nanometers is what is there in most of the latest chips, and the industry is going to 3 nanometers, which is even less. And hopefully we'll see stuff like quantum technology where this could further reduce to maybe an atom level width. But India is actually not going after 5 or 3 nanometers right now. We are going for what are called mature node technologies, which are much higher, 28 nanometers to 65 nanometers. Because our priority right now is to play catch up. We want to build that ecosystem, build the infrastructure, and we don't have the wherewithal to get into 3 nanometers. China might be going for it. US obviously has. I mean, we must have heard that US government has taken a 10% share in Intel now. That is how strategic they are considering, right? There was data that 40% of the chips used in US missiles are actually being sourced from China. So this is the reason why geopolitics is also playing into this whole thing and influencing how things are shaping up. India has to catch up. We have to become self-sufficient. Tomorrow a tariff comes in, we don't want to be left napping, right? So nanometers are critical. It basically means how much you can pack and the cost to performance equation, etc.
So, how big is the market? Coming to our areas of interest, while we understood the tech part of it, uh, what is its significance in terms of its market size? How big is the semiconductor industry?
It's like asking how big is the market for iron, right? It is not just the iron ore industry or the steel making industry. It also goes into automobiles. It goes into pretty much everything, right? So similarly here, the market is as big, electronics, digital, everything, right? But if you had to just tightly define it, it's probably $50 billion right now in India. It was around half of that a couple of years back, and it is likely to touch about $100 to $110 billion by 2030. That is how the semiconductor market in India is shaping up. Now, India has today about 15% of the global integrated circuit design workforce. So there is technology talent in India, and obviously there are a lot of GCCs for the big chip makers in India. So our idea is to first play basic catch-up. Okay. Now I remember 25-30 years back there was a gentleman called Vinod Dham. He became very famous. He was this Indian guy who went with $8 in his pocket, joined Intel, became one of the core chip makers and made a fortune out of it. We need to repeat all of that within India now. We just can't. We need to create 100 Vinod Dhams, and thankfully, at places like IIT Madras, there are focused initiatives, and there are people who are trying to do this chip making at a much lower cost and in a much more tighter time frames, in the matter of days, as opposed to what I heard one of the founders say is that what NVIDIA does in several months, we want to do it in a few weeks. That's the kind of ambition that they have.
Great.
And these guys are going after, all our PSUs are big time consumers of chips. Your DRDO, ISRO, all of them consume. So they're trying to tell them that, look, why don't you use what we are producing, at least for the low hanging fruit. So it's a very systematic process going on at all levels, and hopefully, it culminates in the next 5 to 10 years.
Okay. Ram, so tell us what is the India Semiconductor Mission, ISM as we call it?
The mission of ISM is to build an ecosystem in India where chips, etc., semiconductors are manufactured in India. So it is basically training the talent. It is about encouraging companies to produce in India, giving incentives to companies that invest in this and start making those chips. They're starting with that 28 nanometer node technology so that we play catch up on that fast enough. So we know that, right? To start any new business industry, it requires a lot of capital expenditure. So the government wants to reduce that pain of capex, and they have allotted about 76,000 crores, including up to 50% support in some cases of setting up those plants and all that initially. So it's a massive outlay covering all the areas that we spoke about.
So Ram, we covered a lot of ground, from understanding what is semiconductors to what is its importance, the value chain, and we also understood why this industry has become so important. We also spoke about what the government is doing. Now coming to areas of interest of investors, what does this translate into in terms of which companies are likely beneficiaries of this move, and what should investors do?
Well, first thing is investors should not jump into this saying this is the latest trend. It happened with EVs also. A lot of people jumped in, and you need to realize that there's a huge amount of capex here. So risk is high, which is why government is stepping in with all these initiatives. So you could, from a risk reward profile standpoint, investor could look at the large cap stable companies, and many listed companies are there. I mean, not to take this as a recommendation, but the likes of HCL, TCS are fairly getting involved in the setup of large manufacturing facilities. But they will all take time to play out. So there are large cap companies which are doing this. Then there are some mid cap companies which, Dixon is probably one example, which market cap is growing so fast it could even become a large cap by the time we finish speaking this podcast. But there are those guys in the mid cap space who are working on design electronics, etc. There are some PSUs like BEL also involved. There's a lot of defense electronics happening there. And then there are these smaller companies which are doing specific things like outsourced semiconductor assembly and test. OSAT is an area where there's a listed company which is doing that kind of work. So one has to carefully look at the risk reward profile, understand the space, and get in at the right time, because you don't want to invest before the inflection point comes, because A, you have to patiently wait, and B, you may bet on the wrong horse. End of the day, only few companies will ride any curve of technology, and you have to be at the right time, right place. So that's why I would say one has to look at all of these aspects and invest in the right space at the right time. And as always, our roots and wings philosophy is also important, where you look at companies with good promoters, debt-free, strong balance sheets, consistent earnings, growth, etc., etc. So exciting area to invest in. One has to definitely keep track of semiconductors, because as I said, by 2030 we're looking at 100 to 110 billion dollars, which is a several times multiple where we stand today, and there is no option but to do this. India has to do this, whether you like it or not. The world is becoming a more geopolitically turbulent place, and if you don't invest in this space as a country and build those capabilities, you will be left behind, and there will be beneficiaries out of this. So we got to track and
Keep a tight watch.
Absolutely, keep a tight watch on the right companies, and we are doing that as part of our investment house. We are tracking many of these companies. Many are on our watch list.
Yes.
Some are already in the portfolio, but I think the key is to look for those emerging companies and get in at the right time. That's when we'll give you a wealth creation opportunity.
Thanks, Ram. Very insightful, and I enjoyed listening to you, and hope the viewers who are seeing this also have benefited tremendously from your insights, and will actually do the needful to catch this next wave.
Absolutely. From chip design to fabless manufacturing to testing to electronics, it's a hot space, and let's keep an eye and let's spot those winners early on.
Yeah. Happy investing as always.
Yes, happy investing.